Today's lesson is on parallel and perpendicular lines. It's Unit 4, Section 4 in Apex. Parallel lines this is the symbol that we can use for parallel lines, and parallel lines are lines that never intersect, ever. They never, ever intersect. But another way we describe them is they're lines that have the same slope. Perpendicular lines, which we use this symbol, are lines that intersect at right angles. And a right angle is also known as a 90-degree angle. So here's a symbol here that this little teeny square that's in the corner tells me that these two lines meet up at a right angle, and that is perpendicular. We also know that their slopes are what we call opposite reciprocals. Sometimes people will say the negative reciprocal, but the mathematical phrase is really opposite reciprocal. Opposite means if it was positive, change it to negative. If it was negative, change it to positive. So we want the opposite sign. And reciprocal means to flip it. So here are some examples. If I'm going to go, these are for perpendicular slopes. If I'm going to go from some slope that I'm going to say is m, then the perpendicular slope would be -1 over m, because that would be the opposite and then reciprocal, the flip of it. If I started with a slope of 5 and I wanted the perpendicular slope, I would change it from positive to negative and then flip the 5 and I'd have -1/5. If my slope was -3, well, the opposite of negative is positive, and the flip of 3 is 1 over 3, so it's +1/3. If my slope was 2/7 and I wanted the perpendicular slope, this is positive, I want to go to negative, and then I flip that fraction and I get -7/2. If my slope was -4/13, well, it's going to go from negative to positive, and then when I flip it, I get 13/4. If my slope was -1/6 and I want the perpendicular slope, I would do the opposite, which is positive, and then flip 1/6, and I would get +6. So these are some examples of going from a slope to its perpendicular slope. So we're going to start practicing by looking at these pictures, and we'll see in this first picture that it says they are perpendicular lines. And if the green line has a slope of 4 and they are perpendicular, then we want the opposite reciprocal, and so we're going to get -1/4. In the middle one, we have parallel lines, and parallel lines are the same or equal slopes, so its slope is still -1/2. In the third picture, we have another pair of perpendicular lines. So if the first one has -3, then its opposite reciprocal would be +1/3. All right, so this is just filling in some guided notes. You should take notes on all these. So you're going to start with the point slope form of a line. And for these problems, it really needs to be in this format, this point slope format, so that we can rewrite the new equation that is either going to be parallel or perpendicular. In this case, we're talking about parallel. So for parallel, we start with our original equation in point slope form. We're going to identify the slope from that equation, and we're going to substitute this m in the equation. Y minus y sub 1 equals m times x minus x sub 1. We substitute the given point's coordinates for x sub 1 and y sub 1. And then, just for good measure, to finish this up, so we will then take this and distribute and simplify so that we can get the equation in slope-intercept form. So here is a question in doing this. Find the line parallel to this equation right here, y minus 5 equals -2/3 times x plus 7, We want the line that goes through these points, this 1 point, 3 comma -1. So we identify the slope. The slope is -2/3. We identify the point, and we can write it in point slope form of a line. Now, This is perfectly fine. This is an equation of a line. It is in point-slope form of a line. But if I want to get it into slope-intercept, we need to distribute the negative 2/3, and then we need to subtract the 1. So here I distributed the negative 2/3. So I had a negative 2/3 times x, and a negative 2/3 times 3. Well, a negative times a negative, let me go back. It was negative 2/3 times negative 3. So a negative times a negative is a positive, and 2/3 of 3 is 2. We subtract 1 from both sides, and we end up with this equation, which is the slope-intercept form of the same line. So both of these equations describe the same line. Now we're going to practice for perpendicular. In perpendicular, we want the opposite reciprocal of the slope that's given. So this slope that's in here, this m, we want to find the opposite. So I'm going to say negative, but negative 1 over m. And so we substitute this negative 1 over m for the m that was in the original equation. And then we're going to substitute the new point that we're going to have into the point-slope form. And lastly, we're going to distribute and simplify and rewrite the equation in the slope-intercept form, just so that we can practice that skill as well. So here is a problem we're going to do. Write an equation of the line perpendicular to this one right here. And we've got y minus 3 equals 2/5 x plus 7. And we have a point. Step number 1 is to identify the slope. And then we have to remind ourselves, if our slope is 2/5, then the perpendicular slope is the opposite reciprocal. So negative 5/2. And then we find our point that we have here, 4 comma negative 3. And we can write it in the point-slope form of a line. But we want to practice simplifying this into the slope-intercept form of a line. So we're going to distribute the negative 5/2. And when we do that, we have negative 5/2 times the x, and we also have negative 5/2 times the negative 4. But a negative times a negative is a positive. 2 goes into 4 twice, so it ends up being 5 times 2. Well, 5 times 2 is just 10. So when I do negative 5/2 times negative 4, I get 10. The last thing we're going to do to put this in slope-intercept form is subtract 3. And we have y equals negative 5/2 x plus 7. So we're going to do the practice problems. These are the checkups. And in this one here, we're told that we have parallel lines and that one of them has a slope of 2, so the slope of the other one is also 2. In problem number 2, again, we have parallel lines, and the slope of one of them is negative 3, so the slope of the other is also negative 3. In problem number 3, we have perpendicular lines. And in perpendicular lines, we want opposite reciprocal. And so if the slope of one of them is 1/2, then the other slope is negative 2, the opposite reciprocal. In number 4, once again, perpendicular lines. One of them has a slope of 4, so the perpendicular slope would be the opposite, which is negative, and the reciprocal of 4 is 1/4. We're saying, what is the slope of something that is parallel? Whoops, I'm sorry. I want to go back one there. When we say parallel, well, parallel has the same slope. So we're given the slope of 9, so the parallel line has a slope of 9. In problem number 6, we have perpendicular, and we're given the slope is negative 5, so the opposite reciprocal is positive 1/5. Now we're going to find the equation parallel to that. We have one line, and we want a parallel line that has the point 3, 2. So we identify the slope. They have the same slope. So whatever the m is in one, the slope in one, it's the same as the slope in the other. And we have the point 3, 2. So we've got the point slope, the point slope form of a line. In number 8, This one, it says perpendicular. So if we want perpendicular, one of the slopes, the slope of that line is 1/3, and therefore the perpendicular slope is going to be -3, the opposite reciprocal. And we have the point 3, 2, so we write the point slope form of a line. We could simplify these into slope-intercept as well, but I just want you to get the main idea of parallel gives us the same slope, and perpendicular gives us the opposite reciprocal slope. In this problem, it's a word problem, and they're saying that there's the banks of a river. So the banks of the river are parallel to one another. Whatever the slope is of one is the same as the slope for the other. And then it also tells us something about the parallel bank, or the parallel line, has the point 2, 0. So we've got parallel, we've got the fact that the slope is 2, and there's a point 2, 0 for that line that we're interested in. And therefore we can write the equation. We're going to simplify it because we've got y minus 0. We don't like to leave 0 in an equation. So that just becomes y. We're going to distribute the 2, and you end up getting 2x minus 4. And the last question is saying the bridge, and they're talking about a bridge that's going to be perpendicular. What do we say? I don't see the word perpendicular anywhere in here. Nowhere does it say perpendicular. But it does say a river at a right angle. And remember, that means perpendicular. When two things intersect at a right angle, it's perpendicular. So the slope of the bank is 2, and therefore the slope of the it's a bridge, which is going to be perpendicular, is -1/2. It has the point 0, 2. So we write the equation. Once again, we don't like that minus 0, and we're going to distribute the -1/2. And so that's the end of your checkup.